Hi there, this is bjackal, and this is my first video on showing binary. I've made a video on denary numbers, which you can check out. I will try and put a link on the screen somewhere if I remember. So I'm going to be discussing in this video what binary is and how to convert normal numbers into binary, and then how to convert binary into normal numbers, which is binary to denary and denary to binary. So I recommend you check out the denary video that I made if you don't understand what denary means, because denary is the numbers that we use. So computers are two-state machines, so that means that they're in terms of high voltages and low voltages, and that's why computers operate in binary, because binary is base 2 and it's two states. So these two numbers that are used in binary are zeros and ones. Binary is only zeros and ones. There's no 2, 3, 4, zeros and ones. And that's how you can write in binary. So I showed in the previous video, and I don't want to show how to do it, so please watch it. The column headings for base 10. And in base 2, it all works the same, it's just different numbers. So in base 2, it goes up in 2s. So we have units again, then it goes 2, 4, 6, 8, that's a really bad 8, okay, and then 16, this is going to go off, isn't it? 32, 64, and then 1, 2, 8. This is what happens when I can't afford a proper pen and whiteboard. So, in denary, we have the number 47. Just the first number I thought of, okay? And in binary, each column can contain 2 digits because it's a 2-base system. And 0 counts as a digit, so the digits are 0 and 1. So if you want 47, you have to go to 32, because 64 is too high, and you put a 1 in there, and 32 plus 16 is 48, and that's 1 too high, so you do 0. And a trick is, if it's 1 too high, then all of these are going to be 1. So 47 in binary is 1011111. I don't know if I actually said that right. 1011111. And let's just try with a few more numbers, just so I can show a few examples, just in case you're getting befuddled. It's just a new system. And if you learn how to count binary and you understand denary, and I'll show octal and hexadecimal, base 8 and base 16, then you can pretty much count in any base, and it is useful. Let's just rub out that as well. I probably shouldn't have rubbed out the headers, but it's fine. Okay, maybe I can do a bit more nicer now. U2, 4, 8, 16, maybe not, 32, 64, and 1, 2, 8, at least it fits. Okay, I'm going to give another number, and that is 1, 2, 1. Again, first number I could think of. That's a really bad circle. So 1, 2, 8 is too large, so we're going to put 0 there. That can be represented just ignoring that bit there. You could just show those numbers. But just quickly, there are 8 bits in a byte. So 1, 2, 3, 4, 5, 6, 7, 8. So if you're asked, if this is for an exam and they ask you to represent it with a byte, that you keep that there. But usually you can just get rid of that because the first digit is a 0. It's the same in normal number systems. Okay, so 64, 96, 112, 120, and then it's 0, 0, 121. Okay, so now let's get rid of all of that. So that's how you do it. That should be right. Okay, so that is how you convert denary numbers base 10 to binary base 2. And just quickly some terms that you might want to know about binary. We have something called a bit, which I just mentioned, which is there are 8 bits in 1 byte, and a bit is a binary digit, which is represented as a 0 or a 1. We have bytes, which is a group of 8 bits representing 1 character. A nibble, which I found very funny when I was learning, which is half a byte, 4 bits. So those are very important terms. And sometimes people are going to like split these up into nibbles. So, that's a rubber. So you will see people doing this, and then the numbers they'll split it down there. And this is the least significant bit, and this is the most significant bit. And these are just terms that you might need if you're doing A-level computing or wherever you're studying something, maybe university. They will refer to these terms. If you just want to learn binary, this is still quite useful. And we can now convert binary to denary now. So this is just the first group of random digits I can think of. 1, 0, 1, 1, 0. Okay, and all you need to do is add it up. So 64 plus 30, 96, 112, 116, 118. Okay, so that is a binary 118. Okay, and in the next video we can speak about different representations of binary, so BCD, octal and hexadecimal, which are different bases, which are often used as like shorthand for binary, and that's very common when speaking in computer science terms. And then we can turn about representing negative integers, and then like adding, subtracting, and we can move forward in binary, and then go into more computer sciencey things. So thank you for watching. If you have any questions, please like, rate, subscribe, email me, blah 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 blah. Thank you. This is bjackal.